Hello students, let us know how are electrons distributed in different orbits. The distribution of electrons into different orbits of an atom was suggested by Bohr and Bury. The following rules are followed for writing the number of electrons in different energy levels or shells. The maximum number of electrons present in a cell is given by the formula that is 2n squared, where n is the orbit number or energy level index 1, 2, 3, etc. Hence, the maximum number of electrons in different shells are as follows. First orbit or K shell will be 2 into 1 squared, which is equal to 2. Second orbit or K shell will be 2 into 2 squared equal to 8. Third orbit or M shell will be 2 into 3 squared, which is equal to 18. Fourth orbit or N shell will be 2 into 4 squared, which is equal to 2 into 16 equal to 32, and so on. The maximum number of electrons that can be accommodated in the outermost orbit is 8. Electrons are not accommodated in a given cell unless the inner shells are filled. That is, the shells are filled in a stepwise manner. Point 1. The composition of atoms of first 18 elements with electron distribution in various cells is given. Name of the element, symbol, atomic number, number of protons, number of neutrons, number of electrons, distribution of electron in K, L, M and N shell, valency. Hydrogen, symbol H, atomic number 1, so number of proton is equal to 1. Number of proton is equal to number of electron, so the atom will be electrically neutral. Here the hydrogen does not have any neutrons. K shell contains 1 electron, valence equal to 1. Before looking into this table, let us know how to find out the number of protons, electrons and neutrons. Say atomic number is equal to number of protons, which is equal to number of electrons, so that the atom will be electrically neutral. Second thing, number of neutrons. How will you find out number of neutrons? Mass number minus atomic number is equal to number of neutrons. I repeat, mass number minus atomic number is equal to number of neutrons. Helium, symbol He, atomic number 2, so number of proton is equal to 2, number of electron will be 2. Neutrons, mass number 4 minus 2 is equal to 2. First K shell contains 2 electrons, valency is 0. Lithium, symbol Li, atomic number 3, number of proton is equal to 3 and electron also 3. Neutrons 4. The distribution of electrons, atomic number 3, so 2, 1. First cell contains 2 electrons. Maximum number of electrons in K shell is equal to 2. So remaining 1 goes to the next cell, that is L cell. Valency 1. One more thing you have to remember, that is how to find out the valency. Number of electrons in the outermost cell, that is called valence cell, and the electrons present in the cell is called valence electron. I repeat, number of electrons present in the outermost cell is called valence electrons and the cell is called valence shell. How to find out the valency? If the number of electrons is 1 to 4 in the outermost cell, that will be the valency. If the number of electrons present in the outermost cell is above 4, then it should be subtracted from 8. For example, an element has the atomic number 7, that is nitrogen. So distribution of electrons 2, 5. First K cell contains 2, remaining goes to the next cell 5. How will you find out the valency? Above 4, number of electrons in the outermost shell is 5. So, you should subtract from 8. That is 8 minus 5 is equal to 3. Maximum number of electrons in the cell is 8. So, 8 minus 5 is equal to 3. 3 is the valency. Similarly, for beryllium, atomic number 4. So, number of protons 4, electrons 4. Then neutrons 5. How will you distribute the electrons? Atomic number 4. So, number of electrons 4. So, first cell 2, remaining goes to the next cell 2. The valency 0 to 4. If the number of electrons in the outermost cell is 1 to 4, that will be the valency. Here 2, so that is the valency. Boron, symbol B, atomic number 5, number of protons and electrons 5, neutrons 6. The 5 electrons are distributed as 2, 3. First cell 2, remaining goes to the next cell 3. So valency 3. Carbon, symbol C, atomic number 6. So number of protons and electrons 6. Neutrons also 6. K shell contains 2 electrons, remaining goes to the next cell 4. L contains 4. The valency is 4. Nitrogen, symbol N, atomic number 7. So number of protons and electrons 7. Neutrons 7. K shell 2, remaining goes to the next cell 5. Valency 8 minus 5 equal to 3. Oxygen, symbol O, atomic number 8. So number of protons and electrons are 8. 16 is the atomic mass of oxygen. So 16 minus atomic number 8 is equal to mass number, which is equal to 8. I repeat, 16 is the mass number for oxygen. So number of neutron is equal to mass number minus atomic number. Mass number 16 minus atomic number 8, which is equal to 8. So number of neutrons 8. Distribution of electrons 2, 6. K shell 2, L shell 6. So above 4. So the number of electrons in the outermost cell is 6. It is above 4. So the valency is obtained by subtracting 6 from 8. 8 minus 6 equal to 2. Similarly, the other elements mass number is subtracted by the number of electrons or protons, that is atomic number, which gives the number of neutrons. Fluorine, symbol F, atomic number 9. So number of protons and electrons are 9. Number of neutrons 10. Distribution of electrons 2, 7. So valency 8 minus 7 is equal to 1. Neon, symbol Ne, atomic number 10. So protons and electrons are 10. Mass number minus atomic number is equal to number of neutron, which is equal to 10. So the distribution of electrons 2 in the first cell, remaining 8. Valency 8 minus 8 is equal to 0. Sodium, N is a inert gas. Sodium, symbol Na, atomic number 11. So number of protons and electrons are 11. Mass number minus atomic number is equal to number of neutron is equal to 12. The distribution of electrons 11. So 2, 8, 1. K shell 2, L 8. Remaining goes to the next cell 1. So 1 is the valency of sodium. Magnesium, symbol Mg, atomic number 12. Number of protons 12. Similarly, the number of electrons 12. Number of neutrons also 12. The distribution of electrons 2, 8, 2. that is K, L and M has the electrons 2, 8 and 2 respectively. Since the number of electrons in the outermost cell is 2, the valency is 2. Aluminium, atomic number 13. So number of protons and electrons are 13. Number of neutrons 14. Distribution of electrons 2, 8, 3. 13, 2 plus 8 plus 3. The valency 3 as it has 3 electrons in the outermost cell. Silicon, Si symbol, 14 is the atomic number. So number of protons and electrons are 14. The number of neutrons also 14. Distribution of electrons 2, 8, 4 in K, L and M respectively. Number of electrons in the outermost cell 4. So that is the valency 4. Phosphorus symbol P. Atomic number 15. So number of protons and electrons are 15. The neutrons are 16. Distribution of electrons 2, 8, 5. So number of electrons in the outermost cell, that is valence cell, is 5. That is the valence electron. Valency equal to 8 minus 5. 8 minus 5. So it is having the valency 3. The phosphorus has divalent. That is 2 valencies are there, 3 and 5. Sulfur, S symbol, atomic number 16. So number of protons and electrons are 16, neutrons also 16. Distribution of electrons 2, 8, 6. 6 electrons in the outermost cell, so 8 minus 6 equal to 2. That is the valency. Chlorine, Cl, atomic number 17. So protons and electrons are 17. Number of neutrons 18. Distribution of electrons K, L and M are 2, 8 and 7 respectively. 7 in the outermost cell, so that is the valence electron. The cell is called valence shell. 8 minus 7 equal to 1. 1 is the valency. Chlorine Cl symbol. 17 atomic number. Number of protons and electrons are 17. Number of neutrons are 18. Distribution of electrons 2, 8, 7. Valency 8 minus 7 equal to 1. Organ Ar symbol. 18 atomic number. So number of protons and electrons are 18. Number of neutrons 22. The distribution of electrons 2, 8, 8. Outermost cell, valence cell contains 8 electrons, that is valence electrons. 8 minus 8 is equal to 0. I think you might have understood how to write the electronic configuration, that is distribution of electron, and how to find out the number of electrons, protons and neutrons. If you know the mass number and atomic number, you can able to find out neutrons. Atomic number is equal to number of protons is equal to number of electrons. Look at the diagram 4.4. Here the schematic atomic structure of the first 18 elements are given. You know, the center contains a nucleus. The nucleus contains protons and neutrons around which the electrons are revolving. Hydrogen, number of electron 1. So you draw one shell or orbit or energy level, that is K, and put one dot. Dot indicates electrons. So outermost shell contains one electron. Helium, atomic number 2. So number of protons and electrons are 2. So you draw the nucleus around which the electrons are revolving in a circular path. So 2 dots indicates the 2 electrons. Similarly, lithium, atomic number 3. After completing the first K shell, the remaining electron, one electron, goes to the next cell, that is L. Similarly for other elements, I will explain up to 8 elements remaining, you can able to find out. Beryllium, atomic number 4, so number of electrons 4. First cell K contains 2 electrons, remaining goes to the next energy level orbit or shells, remaining 2 in the L shell. Then next element, boron, 5 electrons, so first nucleus you draw, the center part indicates the nucleus around which the electrons are revolving in the K and L shell. K shell contains 2 electrons, remaining 3 electrons are present in the L shell. Then carbon, atomic number 6, so 2 in the first cell K shell and 4 in the next cell. N, nitrogen, nucleus center indicates the nucleus around which the electrons are revolving in the K shell 2 and remaining 4 in the L shell. Similarly for the other elements. Look at the schematic representation or schematic atomic structure of fluorine. The atomic number, what's the atomic number of fluorine? That is 9. So distribution of electrons 2, 7. First cell 2, second cell 7. You take another example, 17. Chlorine has the atomic number 17. So number of electrons 17. Distribution of electrons, first cell 2, second cell 8 and 7. Look at the schematic structure of Cl. Center, nucleus around which the K shell is present. 2 electrons are in that cell. Then next L cell contains 8 electrons. Remaining 7 are present in the M shell. We have learnt how the electrons in an atom are arranged in different shells or orbits. The electrons present in the outermost cell of an atom are known as the valence electrons. I repeat, the electrons present in the outermost cell of an atom are known as valence electrons. We also know that the outermost cell of an atom can accommodate a maximum of 8 electrons. It was observed that the atoms of elements having a completely filled outermost shell show little chemical activity. In other words, their containing capacity or valency is 0. Of these inert elements, except helium, all the other inert gases have 8 electrons in the outermost cell. Helium atom has 2 electrons in its outermost cell. The containing capacity of the atoms of other elements, that is, their tendency to react and form molecules with atoms of the same or different elements. For example, hydrogen atom combines with another hydrogen atom to give hydrogen molecule. Here, they share 1 electrons each. So, it may be of different elements. NaCl. Na has 1 electron in the outermost cell. Cl has 7 electrons in the outermost cell. So, Na lost its electrons or transfer its electrons to Cl. Cl gains 1 electron from the Na and forming a compound NaCl. This is what given as a different elements or atoms of the same element. I think you might have understand. An outermost cell which had 8 electrons was said to possess an octet. That is, octet means 8. So, atoms react so as to achieve an octet configuration in the outermost cell. This configuration, octet configuration, was attained by sharing, gaining or losing electrons. The number of electrons gained or lost or shared so as to make the octet electrons in the outermost cell gives directly the combining capacity of the element, that is the valency of the element. Consider the 3 elements hydrogen, lithium, sodium. The atoms of hydrogen, lithium, sodium contain 1 electron in the outermost cell. So, for them, it is easy to lose 1 electron. So, they have the valency 1. Similarly, if you consider magnesium, it contains 2 electrons in the outermost cell. So, it is easy to lose 2 electrons. So, valency is 2. Aluminium, 3 electrons in the outermost shell or orbit. So, it easily loses the 3 electrons to attain the octet configuration. So, the valency of aluminium is 3. The number of electrons in the outermost shell of an atom is close to its full capacity. Then, the valency is determined in a different way. For example, fluorine has 7 electrons in the outermost shell and its valency could be 7. But it is easier for fluorine to gain 1 electron instead of losing 7 electrons. Hence, its valency is determined by subtracting 7 electrons from the octet, and this gives the valency of fluorine as 1. So, valency can be calculated in a similar manner for oxygen. Oxygen atomic number 8. So, distribution of electrons 2, 6. It is easier for the oxygen to gain 2 electrons instead of losing 6 electrons. So, the valency of oxygen is 2. We know that protons are present in the nucleus of an atom. It is the number of protons of an atom which determines its atomic number. It is denoted by capital Z. All atoms of an element have the same atomic number Z. It denotes the number of protons they possess. For hydrogen, Z equal to 1 because in hydrogen atom only 1 proton is present in the nucleus. Similarly, for carbon, Z equal to 6. Therefore, the atomic number is defined as the total number of protons present in the nucleus of an atom. I repeat, the atomic number is defined as the total number of protons present in the nucleus of an atom. Mass number. After studying the properties of subatomic particles of an atom, we conclude that mass of an atom is practically due to the protons and neutrons alone. These are present in the nucleus of an atom. Hence, protons and neutrons are also called nucleons. Therefore, the mass of an atom resides in its nucleus. For example, mass of carbon is 12U because it has 6 protons and 6 neutrons. 6U plus 6U is equal to 12U. Similarly, the mass of aluminium is 27U, 13 protons plus 14 neutrons. So, the mass number is defined as the sum of the total number of protons and neutrons present in the nucleus of an atom. In the notation for an atom, the atomic number and mass number and the symbol of the element are to be written as follows. Symbol, and then the mass number should be written as a superscript and atomic number as subscript. For example, nitrogen, the symbol N with left hand side 7 is written as a subscript since it is atomic number, and 14 is the mass number. It is written in the superscript. Written as superscript. Let us learn about isotopes and isobars. A number of atoms of some elements have been identified which have the same atomic number but different mass number. For example, the hydrogen atom. It has the 3 atomic species, namely protium with atomic number and mass number 1, deuterium with atomic number 1 and mass number 2, and tritium with atomic number 1 and mass number 3. The atomic number of each one is 1, but the mass number is 1, 2 and 3 respectively. Some examples are carbon with atomic number 6 but with mass number 12 and 14. Chlorine, atomic number 17 but with mass numbers 35 and 37. On the basis of these examples, isotopes are defined as the atoms of the same element having the same atomic number but different mass number. I repeat, isotopes are defined as the atoms of the same element having the same atomic number but different mass number. Therefore, we can say that there are 3 isotopes of hydrogen atom, namely protium, deuterium and tritium. Many elements consist of mixture of isotopes. Each isotope of an element is a pure substance. The chemical properties of isotopes are similar, but their physical properties are different. The chemical properties of isotopes are similar since they have the same atomic number, but their physical properties are different. Chlorine occurs in nature in 2 isotopic forms with masses 35U and 37U in the ratio of 3:1. The question arises, what should we take as the mass of chlorine atom? Let us find out. The mass of an atom of any natural element is taken as the average mass of all the naturally occurring atoms of that element. That is, mass of an atom of any element is taken as the average mass of all the naturally occurring atoms of that element. If an element has no isotopes, then the mass of its atom would be the same as the sum of protons and neutrons in it. But if an element occurs in isotopic forms, then we have to know the percentage of each isotopic form and then the average mass is calculated. The average atomic mass of chlorine atom on the basis of above data will be 35 into 75 by 100 plus 37 into 25 by 100, which is equal to 105 by 4 plus 37 divided by 4, which is equal to 142 divided by 4, equal to 35.5 U. It means that if you take a certain amount of chlorine, it will contain both isotopes of chlorine and the average mass is 35.5 U. Let us learn the applications of isotopes. Since the chemical properties of all the isotopes of an element are the same, normally we are not concerned about taking a mixture. But some isotopes have special properties which find them useful in various fields. For example, an isotope of uranium is used as a fuel in nuclear reactors. An isotope of cobalt is used in the treatment of cancer. An isotope of iodine is used in the treatment of goiter. Isobars. Let us consider two elements, calcium atomic number 20 and argon atomic number 18. Atomic number of argon is 18, for calcium 20. The number of electrons in these atoms is different, but the mass number of both these elements is 40. That is, the total number of nucleons is the same in the atoms of this pair of elements. So, atoms of different elements with different atomic numbers which have the same mass number are known as isobars. I repeat, atoms of different elements with different atomic numbers which have the same mass number are known as isobars.